Good morning, everyone. My name is Edilberto Vaquero. I'm a project officer at the Netherlands Water Partnership, and today I'm going to present the results of the fact-finding mission that took place in Mexico in the framework of the Innowater program. This mission was developed in order to understand the innovation needs for the water component in the horticulture sector in Mexico. The starting point was to define the geographical focus of the mission. The main horticulture production is concentrated in 5 Mexican states, where the strongest growth is taking place in Sinaloa, Jalisco, Guanajuato, and Michoacán. Sinaloa and Querétaro were the selected regions to identify the actual challenges and needs in terms of water technology. In Sinaloa, medium-low technology is found with the strongest growth and production, while in Querétaro, high technology is found in an agropark concept. Looking at the market situation, quality of the production for international market is and needs to be generally higher than for domestic markets. Most of the production takes place in greenhouses, shadow houses, roofs, tunnels, and pavilions. The average size of protected horticulture exploitations is diverse, as 86% is smaller than 0.5 hectares, 11.5% lies between 0.51 and 5 hectares, and 2.5% in areas with more than 5 hectares. Tomato is the most important crop, which represents 70% of the total Mexican protected cultivation area, followed by cucumbers, peppers, and eggplants. One of the essential components in the production chain is water. The agricultural sector is by far the largest user of water in Mexico. In terms of water availability, 69% is found in the southeast region, while 31% is in the north, northwest, and center regions that comprise two-thirds of the national territory. A high consumption of water to irrigate more than 5.5 million hectares is caused by over-irrigation and inappropriate irrigation system, often using groundwater. Over-extraction for irrigation purposes leads to a reduction of water resources and more salinization of soils, and as a result, crop yield and sustainability of the production systems are affected. In Querétaro, groundwater represents the main water source to supply the demand of the sector, while Sinaloa relies on a gravity-fed network of surface channels flowing from reservoirs. The water cost within the horticulture sector in Mexico has a relatively low price in comparison with other business overhead, such as labor, energy, and consumables. For instance, the energy costs are one of the main financial metrics in relation to water supply. For example, $70,000 per month electricity cost versus $1,000 per month water cost. In the case of corn, the total amount of investment for 1 hectare is $2,000, and from this amount, the water cost represents just $83. The water volume that is used per hectare is around 0.75 cubic meter, and this amount is used 4 times depending on the season of the year. For groundwater abstraction, concessions are provided under the Constitution. The maximum allowable abstraction rates needs to be maintained, or licenses to abstract the water may be lowered. The technology levels, especially in greenhouses, range from low to medium and from medium to high technologies. Low technology, where the common structures are shadow houses, there is a dependency on the environment conditions. It can be found in tropical areas like Sinaloa. The production process is mostly based on soil. This accounts for about 50% of the total area covered for horticulture production in Mexico. For medium technology, the common structures are plastic roof and net walls. It can be found all over the country. Sometimes they have climate control and irrigation systems. The production process can be based on hydroponics or soil. This accounts for about 48% of the total area covered for horticulture production in Mexico. High technology, which can be found in areas in the north of Mexico, the production process is based on hydroponics. The common structures are plastic of glass greenhouses, and they are equipped with automated climate control and irrigation systems or nutrient recirculation. These account for less than 1% of the total area covered for the horticulture production. The systems used in Mexico to practice horticultural activity differ according to the type of crop and the local climate conditions. International-oriented growers use more advanced technology for production due to international demand for sustainable products from export markets and a focus on corporate responsibility. In some cases, where the climate conditions are appropriate for growth, lower technologies can achieve same quality and yield as glass houses, which it can provide a competitive advantage to lower technology producers. During the meeting with growers in the focus areas, it was evident that in general, the implementation of water technology in the protected horticulture in Mexico is low. However, in the visited greenhouses under medium and high technology level, some technologies were observed in the production process. For example, reverse osmosis, sand filters, UV disinfection system, and drip irrigation systems. But what drives the Mexican horticulture sector to go for innovation? Climate conditions. The geographical location of production is essential in deciding what kind of technology is needed. The international demands from export markets, standards for product quality, food safety, and sustainability require more advanced technologies for horticulture production. The return on investment make the technology count. The implementation of new technologies is driven principally in other areas than water saving. Be aware, saving water is not a business case. For instance, decrease on electricity costs, recovering nutrients, product differentiation, increasing the product yield per square meter. What are the specific opportunities? The energy efficiency innovations, groundwater abstraction, transportation and treatment, technologies that enhance production yields, institutional capacity building and policy development based on empirical knowledge, technologies that reduce sodium concentration of irrigation water, selective sodium removal, better programming and forecasting of water demand timelines throughout the growing season, less developed technologies, high impact for large amount of growers. What makes difficult to enter the market? What are the bottlenecks? Political, governmental influence on water use, and a financial level, investment capacity to attract advanced technologies, and a commercial level, gradual shift towards vertical integration makes market penetration a challenge. And in innovation, there is a lack of pilot sites for new innovations. What are our conclusions and the recommendations for you to get into the market? The potential clients that are willing and able to adopt advanced technologies are present but scarce. So you have to focus on clients that are international oriented and serve foreign customers with high demands on quality and sustainable production. On a significant size, at least more than zero point 0.5 hectares, or working in collaboration such as the AgroPark in Querétaro, capable of allocating financial means, producing in locations where the climate conditions are not good enough for the production, like in Querétaro. Technologies to reduce water consumption have not business case. European suppliers should focus their positioning of water technology as sustainable production components that not only save and recover valuable resources in terms of cost, but also provide access for growers to differentiate from competitors, production enhancement methods that not only save cost and provide marketing access, but also increase the yield per square meter. And finally, tropicalization and adoption of technology and business approach is a must. adapt business approach and technology to the Mexican context by local presence with a sales office or representative, ensure that the technology is already proven and is adapted to the local conditions, and using local market needs, for example, energy efficiency and selective sodium removal for new product development and incremental adjustment for existing technologies. Thank you very much for your attention.